Hey guys, today we're going to be learning about trigonometric functions on the coordinate plane. Now in this lesson, what we're trying to figure out is all of our trigonometric functions based off of a point that is placed on the grid here. Now what we can think about this as like we have a point and then we draw a circle centered at the origin. So we have this point xy. Now what we know is that from here to that point, this is the x value. And then from there going up, this is the y value. And then if I were to continue to draw this triangle, I have the diagonal here, the hypotenuse, which is also equal to the radius of the circle. So we know what the x and the y values are for the triangle because of the point, since we're given x and y. But to figure out the length of the hypotenuse, we would have to use the Pythagorean theorem. So to solve for r, it would be x squared plus y squared would equal to the hypotenuse, which is the radius squared. So then to solve for the radius, what we would do is square root both sides. So we would have that the radius would equal to the square root of x squared plus y squared. Now, once we know all lengths of the triangle, we can then figure out what all of the values are for our trigonometric functions. Our angle would be the one that is called the central angle, meaning the angle that comes from the center of the circle, which would be the one marked here. So what we see here is that the y would be the opposite side, the x would be the adjacent, and then the diagonal would be the hypotenuse. So sine is going to equal to the opposite, which is y, over the hypotenuse, which is r. Cosine is the adjacent, so x over the hypotenuse, r. Tangent is the opposite over the adjacent, so y over x. Now in a previous lesson, we learned that cosecant, secant, and cotangent are the reciprocal functions for sine, cosine, and tangent. Cosecant is the reciprocal of sine, therefore cosecant would be r over y. Secant is the reciprocal of cosine, so r over x. And cotangent is the reciprocal of tangent, so x over y. And we're going to use these properties here to now figure out our trigonometric functions when we're given a point. So we have a couple options on how you can figure out all of these values. We have the point which is at 3, 4. So I've given you a grid here in case you wanted to draw out the triangle. The point is at 3, 4. So that means that the x value here is 3. The y value here is 4. So that's the horizontal and the vertical distance. And then to figure out the hypotenuse, we would have to solve for the radius, because the radius is equal to the hypotenuse. So we would do the radius is equal to the square root of 3 squared plus 4 squared. Now again, this comes from the Pythagorean theorem. So as long as you can draw out your triangle, you can also figure out this is Pythagorean theorem, so 3 squared plus 4 squared is equal to the hypotenuse squared, which then simplifies to this. So we have the square root of 9 plus 16. Which 9 plus 16 is 25. So the square root of 25 is 5. So now we have x is equal to 3, y is equal to 4, and the radius is equal to 5. So I like to create kind of like a little chart with all of my values, so that way when I'm figuring out sine, cosine, tangent, I just plug in those values. Let's start with sine. Sine of theta is equal to y over r. So y is 4 and r is 5. Cosine is equal to x over r. So x is 3 and the radius is 5. Finally, tangent is equal to y over x. So y is 4 and x is 3. So that would be my tangent. So this is how you can go about to solving for your three trigonometric functions there. Now let's try with this example. We have the point -4, 2. Now you can do two things here. You can, like I did here, I used the chart, the grid here to plot the point and then draw out the triangle. However, you don't necessarily need to do that. You can just solve for r using the square root of x squared plus y squared, and then create a little chart labeling what is x, y, and r, and then solve for all of the trigonometric functions. So let's try it like that. So this is x and this is y. So r is going to equal to the square root of -4 squared plus 2 squared. -4 squared is 16 plus 2 squared, which is 4. 16 plus 4 is the square root of 20, which 20 can be broken down to 4 and 5. And then the 4 can be broken down to 2 and 2. So this will be simplified to 2 square root of 5, since the 5 was left over. So now I'm going to create my little chart here. So x is -4, y is 2, and r is equal to 2 square root of 5. So now let's find our trigonometric functions. Sine of theta is equal to y over r, so 2 over 2 square root of 5. I can cancel out the 2's, and I get 1 over the square root of 5. But what we learned is that you cannot have a square root in the denominator, so we're going to rationalize by multiplying the square root of 5 to both the numerator and the denominator, which gives me the square root of 5 over 5. So this is the sine value. Now let's do cosine. Cosine is x over r. So -4 over 2 square root of 5. I can simplify the -4 and the 2, which gives me -2 over the square root of 5. And then I have to rationalize again. And I end up with the answer -2 square root of 5 over 5. So this would be the cosine value. Now let's do tangent. Tangent is the y over the x, so 2 over -4, which can be simplified to -1/2. And this would be my tangent value. So that's how we use the x, y, and r to figure out our trig functions. Now let's look at a couple of important identities that will help us with future questions. You've already been exposed to the reciprocal identities. Sine, cosine, tangent, the reciprocals are cosecant, secant, and cotangent. So this is how you write a reciprocal. It's 1 over and then the trig function. Same thing. So if you ever see that, that just means, oh, sine is the reciprocal of cosecant, and vice versa. Cosecant is the reciprocal of sine, and that goes for the rest of the trig functions. Now these two I had shown you in a previous lesson, but we haven't used it yet. But today we will. The quotient identities simply mean that in order to find tangent and cotangent, quotient means to divide. So to find these two trig functions, you can divide sine by cosine, or if you're doing cotangent, it's cosine by sine, since they are reciprocals, so they would switch. So let's look at how we would use all of these. We are given here that sine of theta is equal to 2 over 5, and cosine of theta is equal to the square root of 21 over 5. Find the value of each of the 4 trigonometric functions. So first of all, if sine is 2 over 5, that means that its reciprocal, cosecant, would be 5 over 2. Cosine is the square root of 21 over 5, and since secant is the reciprocal, that means that secant would be 5 over the square root of 21, which we would have to rationalize. So we would get a value for secant as 5 square root of 21 over 21. Now, to find tangent and cotangent. I have two options here that you can use in order to find tangent and cotangent. I'm going to show you one with tangent and then the other option for cotangent. So tangent is equal to sine divided by cosine. This is the quotient identity. So I can take my sine value, which is 2 over 5, and I'm going to divide it by cosine, which is square root of 21 over 5. When you're dividing fractions, what you have to remember to do is multiply by the reciprocal, or copy, change, flip. So I'm going to copy my first fraction, 2 over 5, change to multiplication, and flip. So flip the second fraction would be 5 over the square root of 21. The 5's here would cancel, and that would give me 2 over the square root of 21, which I would then rationalize. And this would give me 2 square root of 21 over 21. Now we know that cotangent is a reciprocal, so you can flip this and write your answer, but you would have to rationalize. Or you can take the original tangent value before rationalizing and flip that. So we would get the square root of 21 over 2. Now another way that you could have solved for either tangent or cotangent is to figure out what is x, y, and r based on the two trig functions that were given. Sine is y over r, so y is 2 and r is 5. Cosine is x over r, so x is the square root of 21, and as we saw earlier, r is 5. So what we know is that x is equal to the square root of 21, y is equal to 2, and r is equal to 5. So if you were going to find tangent, tangent is the y over the x. So the y is 2, and the x is the square root of 21, which then you would rationalize. And we get the same answer for 2 square root of 21 over 21. So this is another way of being able to solve for tangent or cotangent. Figure out what is x, y, and r, and then just use what we know of that trig function to put those values together. Let's try another one. We have here that sine is 2 over 3 and cosine is the square root of 5 over 3. Find the value of each of the 4 remaining trigonometric functions. Sine is the reciprocal for cosecant, so cosecant would be 3 over 2. Secant is the reciprocal of cosine, so secant would be 3 over the square root of 5, which we would then rationalize. So that would give us 3 square root of 5 over 5. Now tangent, I'm going to use the quotient identities from now on so that we can remember those moving forward. Tangent of theta is equal to the sine divided by the cosine. Sine is 2/3 divided by cosine, which is the square root of 5 over 3. So now I'm going to copy, change, flip. So 2/3, change to multiplication, and flip. 3 over the square root of 5. The 3's would cancel, and I get 2 over the square root of 5, which then I would have to rationalize. And that would give me a final answer for tangent of 2 square root of 5 over 5. Now cotangent is the reciprocal. Since I rationalized, I can look at my original tangent value and flip that one. So cotangent would be the square root of 5 over 2. As a reminder, if you did not recognize that you can do that, you can always flip the tangent, the one that you got, so 5 over 2 square root of 5, and then you would have to rationalize it again. So this is another option. And this would give you 5 square root of 5 over 2 times 5, which the 5's would cancel, and I would end up with the same answer of the square root of 5 over 2. Now we're going to look at how to evaluate for trig functions based on any quadrant that it's located, because our trig functions have different signs depending on what quadrant it's located in. So here's a little acronym that you can use to help you remember. Our quadrants move starting from this top right corner over in the counterclockwise direction. So this will be quadrant 2, this is quadrant 3, and this is quadrant 4. All students take calculus. I know this is not necessarily true, but it's a way that can help you remember ASTC. Now what this means is that this tells us what trig functions are positive and where. So these only tell you where the trig functions are positive. In quadrant 1, A stands for all. So all of your trig functions will be positive. Cosine, sine, tangent, secant, cosecant, and cotangent. And I mean, think about it, right? Because in quadrant 1, your x's are positive, the y's are positive. So no matter how you work around it, when you're solving for any trig function and you're using x, y, it will always be positive. The radius, additionally, when you solve for the radius, which is the hypotenuse of any of your triangles, the radius will always be a positive number. Now, quadrant 2, S stands for sine. So that means that sine will be positive. If sine is positive, that means its reciprocal, which is cosecant, will also be positive. In quadrant 3, only tangent is positive. But just like in quadrant 2, if tangent is positive, its reciprocal, which is cotangent, will also be positive. Finally, quadrant 4, C for cosine. Cosine is positive, as well as its reciprocal, secant. So now, if I give you this information about the angle, we can figure out what quadrant it lies in. What I like to do is I like to draw out my grid here and start crossing out. So here it says sine is less than 0. If sine is less than 0, that means that sine of theta will be negative. So I'm going to cross out the quadrants where sine is not negative, meaning positive. Sine is positive in quadrant 1 and in quadrant 2. So I'm left with quadrant 3 and 4. Now here it says that cosine of theta is less than 0. So this also means that cosine is negative. And if cosine is negative, the angle can't be in quadrant 4 because cosine is positive in quadrant 4. Therefore, the angle theta lies in quadrant 3. Let's try another one. Tangent of theta is less than 0. So that means that I'm going to cross out the quadrants where tangent is positive, since this means that tangent will be negative. So that means I'm going to cross out tangent 1, because tangent is positive in quadrant 1, and in quadrant 3. Then we are told that cosine of theta is greater than 0, meaning positive. Between these two quadrants, cosine is negative in quadrant 2, so that means that our angle must lie in quadrant 4. Now let's see how we can apply all of this information. Here we are given that tangent of theta is equal to negative 2 over 3, and cosine of theta is greater than 0. We're going to solve here for cosine and for cosecant. So here are some steps for you to follow. First, we're going to determine the quadrant in which the angle lies based on the information given. So let's start off with that. As you can see here, tangent is negative. So that means that the angle cannot be in quadrant 1 or in quadrant 3, since that's where tangent is positive. Then we are told that cosine of theta is greater than 0, meaning it's positive. So it can't be in quadrant 2 because cosine is negative here. That must mean that our angle lies in quadrant 4. Now, if you're in quadrant 4, we are then going to establish the signs of x and y. In quadrant 4, x is positive, since you can see that that lies with the positive x-axis, and y is negative. So what I do now is I use the value that's given, and you see how we have that negative. I'm going to attach that negative to the correct value, which is the y. So let's examine that a little bit. We have that tangent of theta is supposed to equal to y over x. The y in quadrant 4 is negative, so that means that this negative will be attached to the 2. So it's negative 2 over the x, which is positive, so positive 3. So what I have at the moment is that x is equal to 3 and y is equal to negative 2. What I need to do now is I need to solve for r, the radius. So r is equal to the square root of x squared plus y squared. 3 squared is 9, plus negative 2 squared is positive 4. And that gives me the square root of 13. Now, like I said, radius will always be positive, so you don't have to worry about what sign it is. The only time you have to worry about the sign is the x or the y. So the radius is going to equal to the square root of 13. So now, if I want to find cosine, cosine of theta is equal to x over r. So x is 3 and r is the square root of 13, which now I rationalize. And I get that cosine is equal to 3 square root of 13 over 13. Now cosecant. Cosecant is the reciprocal of sine. Sine is y over r. So that means that cosecant is r over y. So I look here, my r is the square root of 13, and the y is negative 2. So this would be my cosecant. And that would be our answer. Let's try one more. We are given here that tangent of theta is negative 1 over 3 and cosine of theta is less than 0. We are now going to find sine of theta and secant theta. So first, we're going to determine what quadrant we're in, so we know the signs of x and y. Tangent is negative, so that eliminates quadrant 1 and quadrant 3. Cosine is also negative, so that eliminates quadrant 4, since cosine is positive there. So we are in quadrant 2. Now in quadrant 2, we look at our axis here. The x is negative, since this is the negative x-axis, and the y is positive, because it's on the positive y-axis. So if I have tangent of theta, which is equal to y over the x, that means that now, since the x is what's negative, the negative gets attached to the 3. So this is 1 over negative 3. So what does this mean? I have that x is equal to negative 3 and y is equal to 1. So now what I need is I need to solve for r. R is going to equal to x squared, so negative 3 squared, plus y squared, which is 1 squared. Negative 3 squared is 9, plus 1. So we end up with that the radius, r, is equal to the square root of 10. So now we're ready to solve for sine and secant. Sine is equal to y over r. So y is 1, r is the square root of 10, which then I rationalize. And we get the square root of 10 over 10. This is sine of theta. Now we're going to do secant. secant is the reciprocal of cosine. Cosine is x over r. That means that secant is r over x. So we have the square root of 10 for r, and x is -3. And this would be our value for secant. And those are our trigonometric functions on the coordinate plane.